This video we will see set operations. So before going for set operations, let us see definition of set. So set is a collection of distinct elements set is collection of distinct elements. Like suppose I'll define set A as elements 1, 2, 3, 4. So this I can say as a set A. The very first operation on the set we'll see, that is a union, or you can say as set union. So union of two set is defined as a set of elements that are in A or in B or in both. So union of sets is denoted by A union B. So this is a symbol used to denote the union. For example, suppose I have set A with elements 1, 2, 3 and set B as 4, 5. So according to the definition, union of two sets is defined by A union B, which contains elements that are in set A or in B or in both. Means I should include all the elements 1, 2, 3 set A elements and set B elements are 4, 5. If I want to represent this union operation using a Venn diagram, then how I can represent that we'll see. So first of all, I will consider universal set. Universal set is a set which contains all the elements. Usually we represent universal set in the rectangular form. Let us say this denotes the universal set which contains all the elements in the universe. I want to now represent the set union operation. Let us say set A and set B. Now how I can represent the union operation? So union operation is elements that belong to set A or B or both. Means it should contain all the elements of set A as well as elements of set B. So this shaded portion denotes the A union B operation. Next operation is intersection of the set. So this is denoted by this symbol, intersection symbol, A intersection B. So this A intersection B contains a set of elements which are in both A and B, or in short you can say the common elements between the two sets A and B. For example, if I have set A with the elements 1, 2, 3, 4 and set B contains elements 3, 4, 5. So my A intersection B contains elements which are in both A and B, means common elements between the set A and B. So 3 and 4 are the common elements between the sets A and B, and hence A intersection B contains elements 3, 4. Now if I want to represent intersection using the Venn diagram, how I can represent? So again, let us say this rectangular box denotes the universal set which contains all the elements in the universe. I'll denote the two sets A and B, A set and B set. Now I want to denote the intersection. So intersection is the common elements between the two sets. So this shaded portion denotes the common elements between the two sets. This is A intersection B. Next operation is set difference, which is denoted by A minus B. So set difference is the set of elements, or which contains the set of elements that are only in A but not in B. Means set difference contains only the elements of set A which are not in set B. For example, if this same set, if you consider A with elements 1, 2, 3, 4 and set B 3, 4, 5, then my A minus B will be 1, 2, because set difference contains only the elements of set A. So 1, 2 are the only elements of set A which are not in set B. So 3, 4 are the elements which are there in the set B. So I cannot include them in this set difference. Now if I am to represent them in Venn diagram, so this is my universal set. The two sets I'll denote by circle. Let us say A and B. So my set difference contains elements of set A which are not in set B. Means only the elements of set A. So this shaded portion will denote the set difference A minus B. Next is complement of set. Suppose I have set A, so its complement is denoted by A's complement or A dash. So this complement of set is set of elements which are not in set A. So more specifically, if I want to write A's complement, I can write as universal set minus A. So complement of set contains elements which are not in set A. So this is denoted by U minus A. With the help of Venn diagram, if I want to denote, I can write, suppose this is set A. So set A complement, if I want to denote, so it contains elements which are not in the set A, that is U minus A. So this shaded portion, this is U, right? This shaded portion denotes the A's complement, U minus A. So we know the set difference U minus A. So according to the difference definition, it should contain only the elements of set U which are not in set A. Hence this shaded portion denotes the A's complement, that is U minus A. Next important definition is symmetric difference, denoted by A symmetric difference B is the set of all elements which belongs to set A or set B but not in both. Means elements which are not common between set A and B. Elements which are not common between A and B. Means common elements we should exclude. Now suppose I have set A with elements 1, 2, 3, 4 and set B with elements 3, 4, 5. So A symmetric difference B, it should contain the elements belongs to the set A or set B but not in both. Or in short, you can say common elements we should exclude. So which are common elements between set A and set B? 3 and 4. So 3, 4 belongs to set A and also belongs to set B. So we'll exclude 3, 4 and rest elements we can write in symmetric difference. So 1 and 2 are the elements of set A and 5 is the element of set B. So A symmetric difference B contains 1, 2, 5. So if I want to represent symmetric difference using the Venn diagram, how I can represent the two sets A and B. So we should exclude the common elements between the two sets. So this portion denotes the common element between the two sets. So I should exclude that. So symmetric difference should contain elements of set A or set B but not in both. So this is A symmetric difference B. Now we'll see some examples on set operations. Let us say A comma B union A comma C I want to find out. So union operation contains elements of set A or set B or in both. So elements of set A comma B will come in union. Also elements of set B. Set B has element A and C. So A has already come. So we can exclude that. We'll include the element C. So A comma B comma C. Next example. A comma B union A comma B. Now if you observe the second set, so second set contains only one element. That one element is another set which contains the two elements A comma B. So this second set is the set which contain one set as an element. So the union operation of A comma B and the second set is A comma B and whole set as one element. So this is whole set as one element. Next, A comma B union phi. So what is this phi? So this is an empty set which contains no element. So empty set is denoted by using a symbol phi or only the two curly brackets. So empty set is the set which contains no element. So these two sets union, if I am to find out, you will have A comma B. Next, A comma B intersection C comma D. So intersection is set of common elements between the two sets. So if you look at these two sets, there is no common element, and hence a result of this intersection operation will be phi, that is empty set. Next, A comma B intersection phi. So what is common element between A comma B and empty set? There is no common element, so I can write empty set. Next, A comma B comma C minus A. Minus is set difference operation. So set difference is the elements of set A which are not in set B, or I can say set difference contains only the elements of set A which are not in set B. So answer will be B comma C. Next, A comma B comma C minus A comma D. Again it's set difference, elements of set A which are not in B. It will have B comma C only. Next, A comma B comma C minus D comma E comma F. Again it's set difference, only the elements of set A which are not in set B. So that is A comma B comma C. Next, A comma B symmetric difference A comma C. So symmetric difference, we should exclude the common elements between the two sets. So A is the common element between these two sets. So result of symmetric operation will be B comma C. Now next question. For each of the following sets, I need to determine whether 2 is an element of that set. So in the first question, how set is defined? X belongs to R. So here R is your set. So every element in the set R is denoted by X. Every element in the set R is denoted by X. And then what is X? How X is defined? X is an integer greater than 1. So what are the elements that will come in R? Integers greater than 1. So 2, 3, 4, 5, 6, 7 and so on. So this is your set R. Now what is question? I need to determine whether the 2 is an element of that set. So if you look at this set R, 2 is there in the set R. So hence my answer is yes, 2 belongs to this set. I can say 2 belongs to this set R. The next set, so it is defined like X belongs to the set R and X is square of an integer. X is square of an integer. Now what will be the set R? So R contains the elements X, and how X is defined? X is square of an integer. So this R should contain the elements like 1, 4, then 9, 16, 25. So these are the squares of integer. 1 square is 1, 2 square is 4, 9 is square of 3, 16 is square of 4, 25 is square of 5. Now what is the question? I need to check whether 2 is element of this set. So 2 is not a square of any integer, hence R will not contain 2, and hence my answer is no. So 2 does not belongs to this set R. The third set, suppose I'll write set like 2, 2. So if you look at this set contains 2 elements. So this first one 2, and second element of this set is the set which contains the element 2. So this set contains the element 2. Hence answer is yes. Now look at the fourth set. If I write like this, now if you look at this set, so this set contains set as an element. So this is one set, this is second set. So I cannot say 2 as an element of this set, because element of this set are another sets, and hence 2 is not element of this set. Now next we will see subset. So if you have two sets A and B, and if you want to say A is subset of B, then every element of set A should be an element of set B. Then you can say A is subset of B. It is denoted by A is subset of B. For example, if I have set A as 2, 4, 6 and set B as 6, 4, 8, 2. So every element of set A, 2, 4 and 6 is an element of set B, 2, 4 and 6, and hence I can say A is subset of B. Even if my set B, if it would be 2, 4 and 6, still I can say A is a subset of B, because every set is a subset of itself. Every set is a subset of itself. If my set A contains elements like 1, 2, 3, 4 and set B with element 5, 6, 7. So can I say A is subset of B? Of course, no. Because every element of set A is not element of set B. And hence I can say A is not subset of B. There is one more definition based on this, that is called proper subset. So this is denoted by symbol A is proper subset of B. A is proper subset of B. So how it is defined? Whenever you want to say A is a proper subset of B, means A should not be equal to B. A is subset of B, but A should not be equal to B. For example, if you have set A as 1, 2, 3, 4 and set B as 1, 2, 3, 4, 5. So here you can say A is proper subset of B, because every element of set A is element of set B, and set B has one more extra element, that is 5, and hence you can say A is not equal to B, but A is subset of B. But how this subset is? It is a proper subset. The next important definition is power set. So how power set is defined? It is set of all subsets of given set. It is set of all subsets of a given set. If your set is A, then its power set is denoted by P of A. Suppose our set A contains element A, B, C. A, B, C. Then what are all its subsets? That is power set of A. What are all its subsets? So every set itself is its subset. Then phi, that is empty set, is also considered as one of the subset of any set. Then one element, set with one element A can be a subset. Set with one element, that is B, can be one subset. Set with element C can be a subset. Then set with two elements A, B, then B, C. A, C also can be a subset of this set. So these are all possible subset of a given set. Hence, power set of A contains total 8 subsets. So in general, if you have n elements in the set, the power set contains 2 power n subsets. If you see this example, set A contains 3 elements. So its power set should contain 2 power 3, that is 8 subsets. Now let us see one more typical example. Suppose I have set A with the element A, B, then one set with element C, D as one element, and E. Then I have asked which of the following statements are false and why. Suppose take first one, C, D. A set with element C, D is a subset or a proper subset of A. So whether it is true or false. Before that, just recall the concept. Let us say I have set with elements 1 comma 2 comma 3, and I want to check whether 2 is element of this set. So how I can say 2 belongs to the set A, or I can say 2 is an element of set A. If I say whether this is element of set A, so how should I read this? A set with element 2, set with element 2, whether it is element of set A. Set A contains 3 elements, 1, 2 and 3. So 2 is element of set A, 1 is element of set A, 3 is element of set A. But a set with element 2 is not an element of set A. If you want this to be an element of set A, your set A should look like this: 1, 2, 3, and a set as element, one element which contains element 2. Then this statement would be true. Now come back. Now whether a set with element C comma D, set with element C comma D is a subset of A. Just one more thing here. Now when you say A is a subset of B, every element of set A is an element of set B. Every element of set A is an element of set B. Now what are the elements of this set? C and D are the elements of this set. Whether C and D are elements of set A contains A, B, then one set with the element C, D and E. C and D are the not elements. C and D are the not elements of the set A. Set A contains one set as an element in which C and D are element. C and D are not the direct elements of the set A. If you find out all the subsets of the set A, you will get sets as A, then B, then C comma D, set with one set as element, and inside that C comma D. So this is the subset. This is the subset. So this is not the subset, right? And hence this statement is false. Now the second is set with element C comma D belongs to set. Now what is belongs to? Here I have shown the example. If you have set A with elements 1, 2, 3, then I can say 1 belongs to A, 2 belongs to A, 3 belongs to A. Now here what is given? A set with element C comma D belongs to A. The answer is yes. Why? A set with element C comma D, a set with element C comma D is an element of this set A, and hence this is true statement. We can say, instead of yes, I should say this is the true statement. Then third one is C comma D, whether it is subset of A. Now if you find out all the subsets of this set A, as I said, so a set with element A can be a subset, a set with element B can be a subset, then third element of the set A is another set with element C comma D. So this can be a subset, a set with set as one element, and inside that C, D are the element, that can be one subset, and hence this third statement is also a true statement. How I am saying, try to find out all the subsets of the given set. So this will be one subset, this is one subset. The third element of the set is a set with two elements. So how will you write its subset? Another subset with set as one element which contains element C, D. So this is one subset of the given set A, and hence the third statement is true.